All right, so we have something called a perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, so let's just understand what that is in the picture. So the perpendicular bisector, we can see line L is perpendicular to segment XY, and XY has been cut into two congruent segments. It has been bisected. So L is the perpendicular bisector. So if a point P right here is on, here I'll highlight it, point P is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what they're saying is point P, because it's on the perpendicular bisector, is the same distance away from X as it is from Y. So what that means is that the segment PX will be equal to the segment PY. All right, so we also have the converse of that. So instead of starting out with a point is on the perpendicular bisector, we're starting out with a point that is equidistant from the endpoints of a segment. So we know that point P is the same distance from X as it is from Y. What that means is that then that point is on the perpendicular bisector of the segment. I'm going to do an upside down T, perpendicular bisector, just because I don't want to write out the full word again. So then we know that XQ will be equal to YQ, and that XY is perpendicular to line PQ. All right, why don't we try to prove that perpendicular bisector theorem? So given line L is the perpendicular bisector of segment XY, so we know that this is a perpendicular bisector, prove that PX is equal to PY. So we're gonna prove that this is equal to this. So we'll just run through an informal proof. We have this right angle right here. So we know that there's a right angle on the other side telling us that angle YQP is congruent to angle XQP. And how do we know that that's true? We know that all right angles are congruent. So we know that those angles will be congruent. All right. We also know that PQ is congruent to PQ. That is a shared side between both triangles. We know that that will be congruent because of the reflexive property. Now, because we were given a perpendicular bisector, by the way, I didn't mention this, we knew that the right angle was here, it's in our picture, but because of the perpendicular bisector, we have a right angle. That's going to give us another piece of information. We know that if line L is the perpendicular bisector, it will be perpendicular to XY, and it also will bisect XY. So point Q ends up being a midpoint of that segment. So I know that XQ is congruent to YQ. So let's write that out. XQ is congruent to YQ. And we knew that because of the definition of perpendicular bisector. All right, so what we notice, we've got two triangles with congruent sides and the included angle matching up to these congruent sides, or we have two sides that are congruent and the included angle. So we have congruent triangles. So triangle XPQ is congruent to triangle YPQ. And we know that those are congruent by side, angle, side. And when you have congruent triangles, all the corresponding parts are congruent. So what we are trying to prove is congruent. Those happen to be corresponding parts. So now we know that PY will be congruent to PX. And we know that's true because, say it with me, CPCTC. And then just last to be aware of our particulars here, we know that these two segments are congruent because corresponding parts of congruent triangles are congruent. We were asked to prove that they're equal to each other. Well, if segments are congruent, that means that they will have the same measure. So then we know that PY is equal to PX.